The circuit pattern is a rectangle, with the runway on one side and circuit direction is normally to the left. To indicate height over the airfield, the QFE pressure setting is entered on the altimeter. Circuit altitude is usually 800, 1000 or 1200 feet. The circuit pattern starts with a climb straight ahead after takeoff to at least 500 feet, when the pilot starts a climbing turn to the crosswind leg. At pattern altitude, the pilot levels the aircraft and turns to the downwind leg, which is flown parallel to the runway. The pre-landing checks are completed on the downwind leg. At the end of the downwind leg, a turn is made to the base leg, and the pilot starts the descent to land. A gentle turn is then made from the base leg and onto the final approach, the aircraft aligned with the runway center line. The aircraft should be stabilized in landing configuration once established on final approach. Proper direction on each circuit leg is made easier with reference to a prominent landmark. As each turn is made through 90 degrees, it is only necessary to look for a landmark around the left or right wingtip, depending on whether the aircraft is flying a left or right pattern. However, the runway should be monitored to maintain proper ground track. Surface wind speed and direction is normally stated by ATC when takeoff or landing clearance is given. The pilot can also request a wind check at any time. The aircraft will not maintain correct ground track unless the pilot makes allowance for wind direction and speed. The pilot should maintain a small heading adjustment into the wind to follow the correct ground track. Maintaining position parallel to the runway during the downwind leg is important. This is done through reference to the position of the runway relative to the wing. The pre-landing checks are listed in the aircraft checklist and are memorized by the pilot. The checks are performed on the downwind leg and can be combined with a scan outside to look for other aircraft and check circuit position. When other aircraft are in the circuit, safe separation from aircraft ahead is maintained by using a slower airspeed or by making gentle S-turns. Extending the downwind leg should be avoided as the aircraft may leave the normal pattern circuit and even the aerodrome traffic zone. The turn from the downwind to the base leg is started when the runway threshold is at a 30-degree angle behind the wing trailing edge. A strong tailwind may require the pilot to start the turn earlier to compensate for the tailwind effect. Final approach speed is fast enough to provide enough aircraft control while slow enough to land within a reasonable distance. Recommended approach airspeed is usually around 1.3 times aircraft stalling speed. A steeper descent is achieved by using intermediate to full flap. Power is used to control descent rate and angle. 15 to 20 feet above the runway, the aircraft nose is pitched up to level attitude to reduce descent rate. The throttle is closed. The aircraft decelerates as the nose is pitched up further, touching down on the main wheels. As the aircraft slows, the nose wheel is lowered onto the runway and brakes are applied as required. When a safe taxiing speed has been reached, the aircraft is taxied clear of the runway. A safe landing is the result of a well-executed circuit and a stable approach. The pilot starts the descent on the base leg with the runway threshold approximately 45 degrees between the aircraft nose and wing leading edge. This point is dependent on wind conditions and the pilot's judgment whether the aircraft is too high or too low relative to the ideal approach angle. Flap is usually added at this point, and the aircraft is trimmed to maintain proper approach speed. The objective to establish a stabilized powered descent at the correct approach speed as early as possible in the approach. Airspeed is controlled by aircraft attitude. This should remain constant at the correct approach airspeed. If airspeed is too slow, the aircraft is pitched nose down. Too fast, the aircraft is pitched nose up. The aircraft may need to be retrimmed after each change. With correct airspeed established, the pilot can concentrate on approach angle, which is controlled with power. Power is increased if too low and decreased if too high. To maintain correct approach airspeed, nose attitude may need to be adjusted and the aircraft retrimmed after each power change. The final turn is executed when a 15 to 20 degree turn will place the aircraft on the extended runway centre line. If the aircraft will drift through centre line during the turn, a turn up to 30 degrees is allowed. Angle of bank should be maintained until the aircraft regains centre line. On final approach, landing flap is lowered and the aircraft is trimmed to maintain correct airspeed. They aim to stabilise the aircraft in the correct configuration and approach speed as early as possible. The task during final approach is to maintain a constant descent angle, with the goal of touching down on a predetermined point on the runway. If descent angle is not judged correctly, the aircraft may undershoot the runway or overshoot the desired point. The pilot judges the position of the aircraft relative to the proper descent angle and makes any corrections necessary. When established on final approach, the pilot looks for the selected aiming point, usually 150 meters beyond runway threshold. The pilot then establishes aiming point perspective in relation to the horizon. The aiming point remains at a fixed angle to the horizon if the approach is flown at a constant angle, and the aircraft will reach this point if this approach is continued. The aircraft will undershoot the runway if the aiming point moves up toward the horizon, and will touch down before reaching the aiming point. If the aiming point moves down from the horizon, the aircraft will overshoot and touch down beyond the aiming point. If the aircraft is in an under or overshooting state, a power change is probably required. However, this visual cue is only valid at a constant attitude. If aircraft attitude changes significantly, aiming point position will also change. These visual cues are valid to a height of around 50 feet, when runway and ground features then flatten out, and the pilot transfers attention to depth perception to judge flare and hold off. During a stabilised constant aspect approach, the aiming point remains at a fixed angle relative to the horizon. Runway perspective remains constant and the aim point remains fixed. A smooth, stabilised approach requires the necessary corrections to be made as soon as the pilot judges the aircraft is not on the ideal approach. At a particular airspeed and rate of descent, descent angle is determined by the headwind component. With a 10 knot headwind, for example, descent angle is steepened. When landing into a strong headwind, more power is required to reduce descent rate while maintaining correct descent angle. At 300 feet on the approach, the pilot should be in a position to judge approach status based on three elements. Is the aircraft under proper control, at the correct approach speed, landing configuration is properly trimmed, positioned to make a safe landing, and has clearance been given by ATC. If the approach is going well, the pilot continues, one hand on the control column, the other on the throttle. If for whatever reason the approach is not going well, the pilot initiates a go-around. A go-around can be initiated at any point during the approach, but at 300 feet there is plenty of time and altitude to make an orderly climb back to pattern altitude. The landing distance is the distance from the point the aircraft clears an imaginary 50-foot obstacle to the point it stops. The ground run or ground roll is the distance between touchdown and the point the aircraft stops. Several factors affect landing performance. The heavier the aircraft, the faster the stalling speed, increasing touchdown speed and lengthening landing distance. The use of flap allows a slower approach speed, a steeper approach angle, an improved view ahead of the aircraft, and a slower touchdown speed. With full flap extended, the shortest landing distance can be achieved. Reduced air density increases true airspeed and ground speed, even with the same airspeed indicated. A faster ground speed leads to a shallower descent angle unless rate of descent is increased, and a faster touchdown ground speed, lengthening the ground run. The runway surface affects ground run. A grass surface, particularly long wet grass, can increase landing distance by 30% or more. Standing water, snow and slush also increases landing distance and makes directional control more difficult. A runway with a downslope significantly extends the ground run, while an upslope shortens ground run. A sloping runway can also affect the pilot's perception of the approach angle. Approaching an upsloping runway, the pilot can believe the aircraft is too high, while when approaching a downsloping runway, the pilot may believe the aircraft is too low. Wind velocity has a substantial effect on landing distance, and into the wind runway should be used if at all possible, as ground speed will be reduced at touchdown, shortening landing distance. Landing can be divided into three parts: the flare or round out, the hold off, and the ground run. The flare starts at 15 to 20 feet above the runway. The aircraft is steadily pitched nose up to slow the rate of descent, and the throttle is closed, placing the aircraft a couple of feet above the runway. From the point the flare begins, the pilot's attention should be outside the cockpit, as visual judgment during the flare and hold off is governed by depth perception. The pilot looks at an intermediate point down the side of the aircraft's nose. The level off may be too high if the pilot looks too close to the aircraft, and level off may be too late if the pilot looks too far ahead, with the aircraft possibly flying onto the runway without flaring. Where to start the flare, and the pitching up rate required to achieve the hold off, is a matter of experience. The hold off is the process of slowing the aircraft while a few feet above the runway. The aircraft is gradually pitched up as the aircraft slows, without gaining altitude, ensuring it touches down on its main wheels in a nose-high attitude. As the aircraft sinks, the pilot adds nose-up pitch, with the goal of ensuring the aircraft touches down at the correct airspeed, slightly faster than stall speed, with the nose wheel raised off the runway. The control column is held where it is after touchdown, and is used to control the gentle placing of the nose wheel on the runway. With the nose wheel on the runway, directional control is assisted by nose wheel steering, and brakes can be applied to slow the aircraft to a safe taxiing speed. The aircraft is taxied clear of the runway, stopped, and after landing checks are completed from the checklist. It may be necessary to request clearance to taxi to the parking area. During training, it is normal to make touch and goes. Before the aircraft has slowed too much on the ground run, flaps are raised to the takeoff position, full power is applied, and the pilot conducts a normal takeoff. Problems with the landing can be caused by arriving over the runway at the wrong approach speed, or over controlling the aircraft. Failure to flare or hold off enough, or touching down too fast, may cause the aircraft to bounce. It may be possible to continue the landing with the hold off, making a slower touchdown. However, if the bounce is higher, the pilot should go around. A balloon can be caused by pitching the nose up too quickly during the flare or hold off, approaching faster than the correct approach airspeed, failure to close the throttle, or a gust of wind. The aircraft will then climb perhaps 20 feet above the runway, and the pilot should immediately initiate a go-around. A go-around can be started at any point during the approach. To go around, use the following procedure. Apply full power and correct any yaw. Establish a shallow climb attitude, appropriate for the amount of flap extended. Check airspeed and raise flap in stages, adjusting attitude and trim to maintain a safe airspeed, and establishing the climb with takeoff flap extended. Retract remaining flap fully in stages and at a safe height, normally not below 300 feet AGL. Integrate the aircraft into the circuit pattern, climbing straight ahead to circuit height, then follow their normal crosswind path.